Hello and hi to Sir Inche Dr. Mohammad Muzaffar bin Ismail. I'm Revati Kalimuthu and my lab partner Manesi Palanisamy. We are here to explain about our lab 5 waves. Now I'm going to explain about there are 5 type of properties of the wave, which is amplitude, frequency, period, wavelength and speed.
Okay, compare and contrast the behavior of a wave with different damping, tension, and end condition. Okay, for the damping of wave decide how the amplitudes of wave will decrease with the time. If a damping constant increases, then the amplitude wave will decreases rapidly. Increasing damping shows that the loss and of energy of wave is very rapid, and viscosity and friction in the medium is very large. Higher damping indicates the wave will not able to go far. So lower damping, the wave will able to go far until end. For the tension, with the change in the tension in the rope of the speed of wave changes. If we increases the tension, then the speed of wave also increases. The wave flies at higher velocities across the tighter ropes. For the slower waves moves through the looser ropes. Okay. For the fixed end, when the end of string is fixed, the displacement of the string at the must be zero. A transverse phase traveling along the string towards the fixed end which will reflect it in opposite direction. For the loose end, the reflection from the loose end, a pulse will the moves left on the string, which left end is free to move. When the pulse move reaches the loose end, it simply goes flops upward, so the pulse is reflected right side up and back to the right. For the no end, since the end is infinite, the wave produced will pass continuously without interactions. Therefore, a wave does not bounce back.
Now I'm going to explain about the characteristics of the wave and what are their effects. First is amplitude. Amplitude wave is an energy transport phenomena. Amplitude is the height of the wave, usually measured in meters. It is directly related to the amount of energy carried by a wave. Next is wavelength. The wavelength is the distance between identical points in the adjacent cycle or crest of the wave is called a wavelength. It is also measured in meters. Period is a wave is a time for a particle on a medium to make one complete vibrational cycle. As the period is time, hence it's measured in unit of time such as seconds or minutes. Then is frequency. Frequency of a wave is the number of waves passing a point in a certain time. The unit of frequency is hertz, which is equal to 1 wave per second. The period is the reciprocal to the frequency and vice versa. And the last is speed. The speed of an object means how fast an object moves, and it's usually expressed as the distance traveled per time of travel. The speed of a wave refers to the distance traveled by a given point on the crash in a given interval of time. The next is I'm going to show how a wave travels infinitely. An energy that moves through space is an electromagnetic wave, which is light. It occurs all over the world. It oscillates as force disturbs it, just like the rope goes up and down when someone shakes it. But unlike other waves on the axis of water and sound waves, light waves does not need any physical substances to travel such that they can travel through space forever.
So calculate and demonstrate a standing wave. This is a standing wave. The amplitude is 0.23 from here to here. The frequency is 1.25. So lambda is point until here to here. Here is 5. Okay. So the formula is V equals to lambda F. So the lambda is 5 centimeter. We convert to meter is equal to 0.05. So times with the frequency is 1.25. So the velocity of the wave is 0.063 meter per second. Thank you.